We'll proceed summation to integral calculus. Okay, so finally we have start discussing summation to integral calculus. Means there are two forms of integral calculus. One is multiplication. Multiplication can be transformed into integral calculus. There is summation. Also, it can be transformed into integral calculus. This is what we are seeing. What is summation that can be transformed into integral calculus? Is I can divide things into many parts and hop. I can divide things into many parts. I have talked about it in detail that how I can divide things into many parts and then add all the parts. Add all the parts. What do you mean? Okay, I mean very concrete thing. What do you mean? So consider Consider that this is xy plane. This is xy plane, and on top of this plane, I have a three dimension. Okay, on top of it, I have a three dimension. Okay, full of what? Okay, this is xy plane, and I have a three dimension. Three dimension is very different from other places also. Okay, so it is cut little bit, and it is like this. So this is a xy plane, and this is three dimension. Consider this is centered at the origin. This the blue mark that is seen here. I believe it should be seen the blue mark. There is a blue mark. Consider blue mark is the origin 0, 0, 0. 0, 0, 0 is the blue mark. And center of this sphere is 0, 0, 0. Means if I put it inside this, then the center of this sphere would exactly over coincide with the 0, 0, 0. Now half of the sphere is above, half of the sphere is below. This can be one of the case. What is the volume of the sphere? This is a sphere. Consider this is a sphere. What is the volume of this sphere? That is under question mark now. What is the volume of this sphere? Okay, someone would say, do you know the formula of a sphere? I know. What is the formula of a sphere? X square plus y square plus z square equal to a square. That is the formula of a sphere, where z is the height. This is xy plane, means this is x-axis and this is y-axis. Okay, and this is origin, means this is x-axis and this is y-axis and this is z-axis. Then z equal to square root of a square minus x square minus y square is the fxy, function over x and y. What is function over x and y? The function over x and y means that if function over x and y means if this is the origin, this is x-axis. This is origin, this is x-axis, and this is y-axis. This is y-axis, and this is x-axis. If that is the case, this is y-axis and this is x-axis. If that is the case, then this is the first quadrant. This is second quadrant, third quadrant, and fourth quadrant. In the first quadrant, if this is x-axis and this is y-axis, this is first quadrant. If I go along x-axis and y-axis, I select any point here called x comma y, function over x comma y. If I apply formula square root of a square minus x square minus y square plus minus square root of a square minus x square minus y square. If I apply this at any point x comma y, say this point is 2 comma 3 and a, that is the radius of the circle, is 1. Okay, I don't know, it will fall it here. We'll try now. Square root 1 square minus 2 square minus 3 square. It will come in negative, not positive. Okay, we will take a point called 0, 0.2 and 0.3. Now it's possible. It will have a z value and minus z value. Plus minus square root of a square minus x square minus y square is z, where x square plus y square plus z square equal to a square. Z is function over x and y. It is depend upon x and y, where x and y are independent axes. Okay, in that fashion, we have two value of z plus minus a square root of a square minus x square minus y square. One value is above the plane and one value is below the plane, because we took the sphere centered at the origin. Means half of the sphere is above the plane and half of the sphere is below the plane. If that is the case, then at any point we have height and we have width. At every point here, we have heights. If I connect all the heights, if I connect the top point of all the height, it will exactly become like this. Okay, what is volume of this? Volume of anything, volume of this is height into dependent into independent component is the volume. Are you kidding? Dependent is Z, true. Independent are 2. How I can multiply 1 into with 2? I can multiply 1 with 1 only. I have never seen that someone would multiply Z into X, Y. Either Z has to be multiplied with the X or Y. Consider that XY plane is a independent variable, not X and Y. X and Y axes are tagged in the XY plane. XY plane is independent very single. Multiply height, that is Z, with the XY plane, you get the volume. What are you talking about? Consider this is x-axis. I'm sorry, this is one axis and the name of the axis is XY plane. No, this is x-axis. Not necessarily, it can be anything. Consider this axis and the name of this axis is XY plane, and this is y-axis. XY plane axis and Z axis. This is Z axis and this is XY plane as axis. I'm not talking about XY plane. XY plane I have constructed in one axis and this is Z axis. If that is the case, then for each point on XY, each point on XY, what is Z value? If I multiply these two, Z into XY plane, it will give the volume. Z into XY plane will give the volume. Okay. Further, someone is free to break the XY plane into X and Y. Y into X will give the area. If this is X axis, this is Y axis. Height by width will give the area. If this is XY plane and this is height, then height by XY plane, height multiplied by XY plane will give the volume. If this is density and this is XYZ plane, then density into XYZ axis, X not XYZ plane, XYZ cube, density into XYZ axis will give the net weight. Okay, so the volume, how to calculate volume? Calculation of volume is Z into XY plane. Since X and Y, they are independent to each other, they are at 90 degree to each other, I can write as dx dy, and height I can write as fxy. Okay, I mean height fxy into xy plane is the volume. If I multiply height with the xy plane is area. Area multiplied by the height is volume. So height into xy plane axis is the volume. Okay, now I can write height, that is z, into xy. Since z is dependent upon xy and xy is independent, I can rewrite as height, that is z, into d of xy is the volume. Height, that is z, I can rewrite as function over x and y. F small bracket x comma y bracket close. Fxy, d of xy, I can write as dx dy. Fxy dx dy will give the volume. Now this is now dx dy is now integral now. Dx dy is integral. What is integral? Okay, integral in a sense that if I am talking about a volume, then height into area is the volume. So height is z, that is variable with the x and y, into the area. What is your area? area is x square plus y square equal to a square. That is the area on the xy plane. Still, radius is a only. Their area on xy plane is a circle. If I draw this, if I just insert it here, then it will go and map into xy plane as a circle. Okay, so it will map like a xy plane. It will map like a circle with radius a again, where the radius of the sphere is a. Makes sense? Now, in that fashion, the kind of the volume expression is fxy d of xy, fxy dx dy. Integration. If I say fxy d of xy, then what is the? I'm sorry. Okay, the volume is z, that is the height into base area. Height, that is z, into xy area. Xy area, that is circle, into height is the net volume. Okay, this is a pseudo code. Multiplication turned into calculus. So height, that is z, into xy plane, that is a circular area, is the volume. Height, then I can rewrite it. Since xy is independent component and z is dependent component, I can rewrite as z into d of xy. Now xy was a circular area. If I write d of xy, I see the expansion of the area. Then I will provide this detail through limit now. Now if I convert xy to dxy, then whatever the xy was the reason, that will be now specified by limit. So started with the volume as height into base area. Height is z, base area is xy plane, that is a circular region. So z into xy plane circular region is the volume. Then z into d of xy, because xy is independent and x is dependent. Fx function over x comma y, fxy dxy. Now since I place d in front of x and y, now this circular area, now I have to represent through limit. Limit circular area. I can say limit. The integration sign when I make, that is actually limit. Bottom of limit, I can say that limit is of a circular area and fxy dxy plane. Okay, what is the circular area? That is x square plus y square equal to a square. That is the circular area of the base. Makes sense? It is quite easy. Height into base area is the volume. Can you prove that? Okay, if I take Cartesian coordinate, the most homogeneous shape is cube. Now anyone can try. In cubical region, take the base area, multiply with the height, that is the actual volume. No one need calculus here. If somebody is trying with calculus, trying to calculate volume, take the simplest shape. And if it is Cartesian coordinate system, simplest shape is cubical region. Cubical or rectanguloid or whatever comes in mind. Where base area into height is the volume. Right, same thing here. Height is z into base area is circle. So height is z into xy plane circular area is the volume. Now height is function over x and y, where in cube height is not function over x and y, it is constant, but here it is a function. So z will be replaced by fxy. Since it is a function over, I mean it will change with the x and y the height is. Since it is a function over x and y, it gives a hint toward x and y being the independent component and z is dependent component, whereas in cube z is not dependent upon xy plane, it is always constant. But here it varies. If there is a multiplication of two items and one item varies with another item and that item is independent, we have to use calculus now. We cannot do direct multiplication the way it did in the calculation of the volume in the cube. So fxy into xy circular region, I have to rewrite it. Fxy into d of xy function over x comma y into d of xy. Limit of the xy will be a circular region. The whatever the circular region was the xy plane, that circular region will come in the limit now. Limit circular region. What is circular region? X square plus y square equal to a square. So limit sign x square plus y square equal to a square. fxy d of xy plane is the volume. Fxy d of xy plane can be written as dx dy because x and y are at 90 degrees to each other. So dx dy, fxy dx dy. Integration sign, and now integration over circular region x squared plus y squared equal to a squared. Now someone would say, can you break this circular region now? Means repeatedly you are saying that circular region, circular region, circular region, circular region. So what is the circular region? Can I notify? That's what I'm saying. Circular region means a limit. Circular region that is x square plus y square equal to a square, or rather than someone would say x square plus y square less than equal to a square. Because for full region, if I say x square plus y square equal to a square, more or less people think it is a circumference area, one line, that is x square plus y square equal to a square, the peripheral line. So region is actually x square plus y square less than equal to a square. Over it, the xy plane that we are talking, xy plane is spread across. So fxy dxy plane or dx dy, xy plane is spread across the limit that is x square plus y square less than equal to a square. Now someone would say, can you break this into x and y? Certainly, we will break it into x and y. Now if I see the circular region, hope. If this is the circular region on xy plane, I rotate it. This is the circular region. Now, if this is x-axis, then y is confined to a curved line. It is not a flat line. If it is a flat line, above x-axis, y-axis, y is like this, then it is not dependent upon x. You move whatever you move along x-axis, y will always be a parallel to x-axis, but that is not the case. Here also y is changing. In 3D, z was changing everywhere when x comma y we are changing, but in limit also, if I go to limit, again x-axis and y-axis, y-axis is changing when x-axis is changing. How much y is changing? Okay, if I take x square plus y square equal to a square, then y equal to plus minus square root of a square minus x square. Means this side it is minus square root of a square minus x square. X, this is origin. X goes from minus a to a. In that fashion, a square minus x square root, whatever comes, if I take minus, then this is the minus y. Then minus y is varying like this to plus square root of a square minus x square. It is varying like this plus. So y is minus square root of a square minus x square to square root of a square minus x square, because y varies with the x and x is minus a to a. So now net volume is minus a to a, that is x, and minus square root of a square minus x square to square root of a square minus x square, that is y. fxy dx dy, that is the volume of the sphere. This is called bringing into integral calculus from the multiplication. We started with the multiplication, that is height by base area is the volume. You don't have any other arrow in your whatever circus. So quiver, I believe you don't have any arrow in your quiver. Okay, we have. So how we can find volume in another way? Let's consider this is the three dimension, and this is x-axis, this is y-axis, and this is z-axis. Now let's cut it into a square. Means this is, consider this is the volume. This is x-axis. Let's cut not this one. Means this is the x-axis. So I cut it into z-x plane. So many chop I make, and then I cut in YZ plane, so many chop I make. Now there are thin region I see where one region has a width of, consider I make n chop along x-axis and I make n chop again along y-axis. Make sense? Now if I chop like this, then I have a 3D section that is coming which has a width of if this the width of this sphere is 2. Consider radius is a. Then width of a sphere in x-axis is minus a to a. 2a is the width. If I cut in n part, each part has a width of 2a by n. Again, I cut in YZ plane. Now I have a small square area or rectangular area on the xy plane. On the xy plane, if I see, I have a rectangular area and then full height. These are now n section I am finding it, n number of it. Each number has a width of 2a by n, and this side y-axis again 2a by n. If I chop it into n section like this and m section like this, m for monkey, m section like this, then every section has a width of 2a by n, and this width, length and height, this is 2a by m. Okay, now each section, if I take each section, then what is the volume of one section? Consider what is the volume of ith section. If I do summation, if I add all the section, I get the volume. This is another way. That is summation of I equal to 1 to n. Summation of I equal to 1 to n. And then summation of I equal to 1 to n. And volume of the ith section. If I add all the volume, I get the net volume. Okay, at least I have not found it in any of the books. So this is the another way of calculating the volume of something. What is volume of something is cut the volume into so many parts. Take ith part. Okay, I start with the 1, 2, 3, 4, 5, 6 like that. Okay, if this is the origin and this was the sphere intersection on the xy plane, I cut into many parts. And now I have started counting it from the bottom left side: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, like that. So many I am counting now. Okay, or if I count in the row and column fashion, then ith row and jth column. Summation I equal to 1 to n, makes sense, and j equal to 1 to n. Okay, because we have how many sections we have? We have section as n into n. That many sections are there, n into n, where summation I equal to 1 to n and summation j equal to 1 to n. Now it is n into n. Now what is the volume? Consider volume of like that, and then volume of the ijth section. Volume of the ijth section is the volume of this. I'm sorry. If I divide into, this is x-axis, y-axis. I say this is I. If I have chopped into n part, then I start from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N. Again, y-axis I have chopped into n part. Consider n part only. Then from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then this corner left will start from the ijk. This is, if I say this is IE1 and this is x-axis. So this is y-axis. This is origin. Then this is I is 1 and j is 1. Like this I'll proceed. Summation I equal to 1 to n. Summation j equal to 1 to n. Volume of the I comma jth section. V volume V bottom right I comma j. Now if I add all the volume of all subsection, then I'll get the volume. Anyway, now we will try again the much awaited area. Then we will tackle the volume. This is one of the way. This is also one of the way of calculating the volume without calculus, doing through summation. Okay, someone would say, boss, are you mad or what? Means how I can calculate this volume for if n tends to infinity, then no, don't make it n tends to infinity. Let 10 by 10, then 100 chops are there. Now someone can do. Calculate the volume of I equal to 1, j equal to 1, I equal to 1, j equal to 2, I equal to 1, j equal to 3. like 1 to 10, 1 to 10, 1 to 10, 1 to 10, like that. Calculate and then you see it. Okay, then how much it will come. Anyway, this is one way. There can be many ways. I'm sorry, this is the one way in a sense I cut in x-axis and y-axis. Are there another way of cutting it? Okay, these examples are not there. I will take simple example in cutting only. Okay, as I promised that we will revisit the circular example. What is the area of the circle? We are actually trying to manipulate the two-dimension two-dimension repeated summation. Two-dimension repeated summation means I have x-axis and y-axis as independent component, and I have z-axis. I have xy plane, and then I have z-axis. To get it there, now I'm trying to get the area of the circle. If this is x-axis and this is y-axis, this is x-axis, this is y-axis. Now consider this is the radius. This is x-axis, this is y-axis, this is xy Cartesian coordinate system. If this is the radius and radius moves from the x-axis and it goes like this, then it makes angle theta. There is another coordinate system called r theta coordinate system, that is also called polar coordinate system. So if I take radius from the x-axis and I start moving it, then I start chopping it. First chop, second chop, third chop, fourth chop, like that we are making chop by chop. So I can divide this circle. I can divide this circle into many chop. First chop, second chop, third chop, fourth chop. Like that I divided the circle into n different chop. Whereas volume we had tried with chopping into xy plane, chopping in xyz plane. Here, I can also chop in x and y. This is not a z axis. There is no z axis here. I can chop along x axis. That's it. I can chop along x axis. I'm not saying I can. Then I chop y axis. I can chop along x axis. Okay. Then I have area. I add all the area. Or I can chop along x axis and then chop along y axis. I have so many small sections. I can calculate the area of all the section and add it, or I'll chop in a polar coordinate way. Means I chop in that fashion. If I chop in a polar coordinate way, if I chop in a polar coordinate way, then how I can find the area of the circle through repeated summation? Then summation sign I equal to 1 to n area of the ith section. If this is the first section, this is second section, this is ith section. If I know the area of any ith section, like that, add all the section, you get the area of the circle. Summation I equal to 1 to n area of ith circle, ith section, that will come as a wedge. It won't be a triangle. It will become as a wedge, because this will come like this. This will come like this, wedge, where two sides are radius and one side is arc. Anyway, okay, the caveat here is r anyway. Now if I try this, then what will be the area of the IS section? Then I have to sum for the all the section and I get the circular area. If I talk about the area of the IS section, this is r and this is r, and this is the arc. From x-axis it makes angle theta, and this axis is delta theta I. This axis is delta theta I, and from x-axis it is theta. I mean that from here till here, I was in section number 1, 2, 3, 4, 5, 6. Then I entered into ith section. This section, this is delta I, and from x-axis it makes angle theta. This is delta theta I. Delta means it has a span of some section, ith section. What is the arc length? R into delta theta I is the arc length. Okay, in that fashion, what is the area of the ith section? If this angle is very small, this arc can behave like a straight line. If it is a straight line, this straight line will fall exactly 90 degree upon this radius. Means more or less it forms a triangle. triangle in a way that this line and this arc line and this line, this forms a triangle where this is 90 degree to it. The length of this arc is r delta theta I into r. So r delta theta I, that is the arc, into r by 2, because this is a triangle. Area of the triangle will be half of the rectangle it makes. So base into altitude by 2 is the area of rectangle. So 1 by 2 r square delta theta I is the area of one section of the curved section. So summation I equal to 1 to n ai is the area of the circle. Summation I equal to 1 to n 1 by 2 r square delta theta I is the area of the circle. Consider r is not constant. If r is not constant, consider r is not constant. In a way, r equal to, many times I have given example, r equal to cos theta. R itself is changing when I move. So this is x-axis and r is like this. When angle is 0, radius is exactly till end of the circle. Now when I move the angle, radius starts shrinking. And when I am at 60 degree, then radius is very small and initial radius was this. Radius is shrinking. Then now consider this is the ith section. Now beginning of the ith section radius is this. After traveling delta xi, radius becomes this small. Will this formula will hold true again? We imagine so, because now the area of the triangle form is like this. Still this arc will fall at 90 degrees this on this radius. Okay, if I consider this arc is a straight line, still the area of this triangle, consider this is R1 and this is R2. Then this line that falls on R2, its length is R1 into delta theta I. So R1 delta theta I into R2 by 2 is the area of this triangle. Now we have the area of the net complete area of the circle by summation is I equal to 1 to n number of partitioning I made. Summation I equal to 1 to n 1 by 2 r2 into r1 delta theta I, where r1 and r2 are function over theta. In that case, I can rewrite as r2 is function over theta plus delta theta I and r1 is function over theta. Considering delta theta is very small, now I can rewrite as summation of I equal to 1 to n 1 by 2 function over theta into function over theta into delta theta I. That is 1 by 2 function over theta whole square delta theta I. Okay, now this is the normal thing that we have seen. Someone can calculate. Now this can be brought into integral calculus. Why it can be brought into integral calculus is integral calculus of summation I equal to 1 to n. Summation I equal to 1 to n fx. Makes sense? Summation I equal to 1 to n, where for any x distance I have chopped. Please watch our previous two videos, very priceless video. So if I have x-axis, I have chopped x-axis. Consider this is 0 to alpha on x-axis. If I have chopped this into n different parts, if I chop this into n different parts, then 0 to alpha, each part has a width of alpha by n. Anyway, now here we have if this circle, consider this circle goes from 0 to 2 pi angle. This angle is chopped into n different parts. Summation of I equal to 1 to n, where n tends to infinity. But area is 1 by 2 function over theta whole square delta theta I. If I have any expression where we have summation of 1 I equal to 1 to n function over x, where x belongs to ith section. If I chop into so many parts ith section into delta xi, this is a fit case to get transformed into integration x is from 0 to alpha. If I have bisected here we have 1 by 2 function over theta whole square delta theta I. We have chopped theta angle into n different parts. In that sense, integration will be theta equal to 0 to whatever is the maximum theta, to limit where we have chopped. Circle is not necessarily that closed circle will be angle 2 pi, not required. We have seen it that when r is function of theta, r equal to cos theta, in that kind of function 0 to pi, 0 to 180 degree also makes a full circle, not required 0 to 360 degree. Mind blowing, amazing it is. So only 0 to pi. Oh, someone would say, how are you kidding? Angle from 0 to pi will make half of the circle. Someone can try. R equal to cos theta. If someone start making a circle when R angle is 180 degree, the circle is complete. In that section, theta is 0 to pi and 1 by 2 function over theta whole square d theta can be converted back from summation I equal to 1 to n 1 by 2 function over theta whole square delta theta I. How it is? Please watch our previous two videos. How it is. Okay, why it should not be? That also previous. Now we are in different discussion actually. Now the question is arising that can we calculate the ith section? Now this is through approximation, where we approximated that the arc is a straight line and it is falling like this and assume this and this and this and this. Without assuming, can I calculate the ith section area? That is under question mark. Summation of I equal to 1 to n. N, AI is the net area where angle is divided into many sections. Now, AI section, can I get without any approximation? Certainly we can get. How we can get? Now consider this is ith section. Consider this is ith section. If this is ith section, then it is formed by four things. Four things. There are four things that is, there are, okay, there is R that varies. There is R that varies. Here, here at the, this is x-axis and angle is theta. This angle is delta theta I of the ith section. Now angle is changing. At the beginning angle is theta. At the end angle is theta plus delta theta I. In this ith section, theta is varying. In ith section, R is also varying. If this is R1, this is R2. There is delta R. R1 minus R2 is the delta R. Okay, this theta and this theta, if I substitute that is delta theta I, is again, so delta theta I is there, delta theta R is there. I'm sorry. Delta theta, bottom right I, ith section delta theta is there. Delta R I, ith section, how much is the delta R we are seeing? Change in delta. That is also there. Okay, now there is, now if I say that if I take any point x comma y, any point x comma y, and if I make 1 unit of change in the angle, consider this is the beginning of this ith section, and here this is the radius at the beginning. Now if I grow 1 unit of angle, 1 unit can be anything, 1 milli radian, 1 picoradian, 1 microradian, anything, not one radian, any 1 unit. If I move 1 unit of radian, okay, if I move 1 unit of radian, then how much x and y is moving? What is your x and y? Consider that there is a point here, called x comma y. After all, this is x-axis and this is y-axis. This is radius and this is angle. We have done a hybrid case of x and Cartesian coordinate and polar coordinate system. Now at angle theta from x-axis we have radius now. If I move 1 degree of angle, then how much 1 degree of angle, then how much of the area I see in xy? What area I see if I move angle, then this is the area. That can be described through r and theta also, but it can be described through x and y also. Consider at this point, any point, there was one x comma y. If this is x comma y, okay, consider this is x comma y. If I move 1 unit, then x comma y is here. Means it made this area in term of x comma y. Okay, I'll take in a simpler term. Okay, simpler term, consider at the beginning x comma y is here. If I make change of 1 unit in theta and r, x comma y came here. Make sense? Okay, understandable, not understandable? Let's take 3D. Okay, then we will see. This is xy plane. And xy plane, I have any point on xy plane at x comma y. X comma y. For that, if I go up and I see a point here called x comma y comma z, Now from x comma y, I move 1 unit in x and 1 unit in y. So this is xy plane. I move this xy plane like this. Now, now this is x comma y. I move 1 unit in x and I move 1 unit in y. Now there is a new point here. Now there is a change of 1 unit of area on xy plane. If I do so, then the point where x comma y is there, there is a point here called P, and a point where x comma x plus 1 comma y plus 1 point is there, there is another point here. Because of the movement, it touched another point here called P2, P and P2. Now here, if I have this P and here I have P2, P correspond to x comma y and P2 correspond to x plus 1 comma y plus 1. If I if I draw on one area here, how I can draw area between 2 points? If this is the point and this is the point, then if this is the point P and this is the point P2, how I can draw area? Take a vertical line like this and take a horizontal line like this. This is the area. If I move 1 unit in XY plane, how much P to P2 area it changed in 3D? Similarly, here here in along x-axis, if I move 1 unit in angle, if I move 1 unit in angle, then angle change is 1 unit. In that fashion, radius also changed. Radius was this much earlier, radius reduced little bit because radius is function over theta. If there is 1 unit of area change because of theta and radius, makes sense? Then how much point, if there was any point here x comma y, the new point I see here P2, this is P1, P x comma y, then new point came. Consider this came as new point here, x P2, x2, y2. How much is the area change? How much is the area change because radius change delta r and theta change 1. Makes sense? Consider radius change is also 1. Means net area change. Theta I change 1 and in that fashion radius also change 1. This is not possible because radius is function over theta. Consider area change in theta and r. Theta delta theta into delta r is 1. Makes sense? Now if 1 unit of area change in theta and r fashion, delta theta and delta r, how much x comma y point jumped now? Earlier consider x comma y is here. Now it jumped to here. Earlier point is P x comma y. Now P came here. P2 x2 comma y2. Underneath it, if I connect these 2 points like this, then how much is the area change? If I denote this x comma y as a vector, that is P vector, okay, then x2 comma y2 is P2 vector. If I denote this x comma y, if this is origin, then P1 vector. If I denote another point because of the 1 unit change in theta, delta theta and delta r, another point is x2, y2. P1, P, P2, P2 vector minus P1 vector is another vector in this direction. This vector is the, consider this is the vector, that is the area vector. Makes sense? If someone will say, no, no, that is not area vector, that is the arc vector. Okay, consider that I have a point P that is x comma y. Now I write what is the delta P I see, what is the change in P I see when there is a change in a unit area in r and theta. R and theta is the unit area. Means if I change angle and if I change radius, then x point would start changing in 2D direction, not in one direction. Make sense? It looks like it will change in one direction, that is P2 minus P. P2 minus P will be a straight line. Consider it is changing in area fashion. I mean, there are so many x comma y it is changing. No, I don't consider. How there are so many x and y it is changing. There are so many x and y it is changing. How it is changing? Now consider it makes angle theta with the x-axis and I change delta theta I. I did delta theta I. And then I am trying to see how much area change. If I change delta theta I, then how much is the area? Area change means right now there is no area here. If I move delta theta I, when at the base angle is theta, then radius change R1 to R2. an angle change theta to theta plus delta theta. If I make radius change r1 to r2 and theta from theta to theta plus delta theta I, how much is the area I am getting? That area is the area of Ath section. Summation of I equal to 1 to n. Ai is the net area of the circle. Now here, consider, rather than moving delta theta I, that is also very small, I moved 1 unit. If I move 1 unit, then x comma y change to another point x2 comma y2. Then I move 1 unit again. Like that, from beginning location till delta theta I moved infinite unit. Makes sense? Then x comma y start changing here, there, here, everywhere, because I'm changing it one by one by one. Between theta to delta theta I moved radius infinite number of times. Every time I have x and y is dancing here and there. If I catch all the dancing point, it will make a area. Okay, now it is all right. What I'm trying to say, how much is the area change in xy plane when there is a unit change I see in the theta r plane? Okay, I'm trying to say, if xy plane means how much, not to address the area in xy plane, I address it through vector. So I am trying to say how much is the delta p. If x comma y I address through x and y, there is a point called x comma y, and I address to a position vector p, then I am trying to say how much position vector change in area fashion delta p, because there is 1 unit change in theta and r. To get that, I'll find how much delta p change when there is delta r and delta theta change in theta and r. Means delta p by delta theta and delta r, delta p by delta theta into delta r will give how much position vector is changing per unit change in the area, delta p by delta theta r. Means how much is the change in area I see if there is 1 unit of angle change and radius change. In that sense, delta p by delta theta, if from here to here, that is delta theta I change is there and delta r change is there, then if I multiply delta theta and delta r, that is the area change in the theta r plane. Okay, means delta p change in position vector, this is x comma y, and this is now after delta theta I knew is x2 comma y2. Delta p, how much is the area change? From here to here we saw I took many sections and everywhere I saw the x and y, and it forms this full surface. Delta p is the full surface change. How much is the delta p per unit change in the delta theta and delta r per unit area? If I know that much, if I multiply back with the delta theta delta r, I get the net area. Makes sense? If person is running 80 kilometer per hour, if I multiply by hour, I get the how many kilometer he is traveling. Makes sense? 80 kilometer per hour one vehicle is running, or a person is running 8 kilometer per hour. If I multiply with the 2 hour, I get 16 kilometer. Similarly, if this area is changing delta p per unit change in delta theta into delta r, okay, per unit change in delta theta into delta r, then if I want full delta ai, then it is delta p, that is the per unit change in area delta r and delta theta. If I multiply with the delta theta and delta r, I get the area of ith section. Makes sense? What is the change in area per unit change in the area of delta theta delta r? That is delta p by delta theta into delta r. Okay, this will bring as a vector, because p is a vector, then delta p is also a vector. Divided by delta theta delta r will be a vector. Its magnitude. This is velocity. If I multiply back with the delta theta delta r, whatever I want, if the speed is 8 kilometer per hour, if I multiply with that how many hours per I want, then I'll get the net area. If I know the change in area per unit delta theta into delta r, if I multiply with for how much you want, then I get the area of that section. So per unit change is change in delta P by, if I make delta theta delta R change, delta P by delta theta delta R magnitude, and then I want for, this is for 1 unit. If I divide by delta theta delta R, it is for 1 unit only. Okay, what is 20 by 4? If I say there is a movement of 20 in numerator, when there is change of 4 in denominator, then it is 5. Means per unit change in denominator brings 5 unit change in numerator, 20 by 4. Similarly, if I say how much the delta P change, X change from here to here, if there is a change in angle is delta theta I and change in radius is delta R. If I talk about the area of section, that is delta theta into delta R, and change is position vector is delta P. Delta P by delta theta into delta R is how much P is changing per unit, delta theta delta R. Multiply by for how much you want. I want for delta R and delta theta only. Means magnitude of delta P by delta theta delta R into delta theta I delta theta R. I want for delta theta I delta theta R will give the AF section area. Okay, that is dP by d theta dr. dP by d theta dr. Delta P by delta theta delta R magnitude into delta theta I delta theta R. This is the ith section area. Now summation I equal to 1 to n magnitude delta P of the ith section by delta theta I delta theta R magnitude into delta theta I delta theta R is the ith section area. Now we have to sum it for all the section and we will get the area. This is without any approximation. This is exactly, we will proceed on this. This is a to key to enter into 3 dimension. Idea is to talk about the multivariable 3 dimensional repeated summation. So that we will see that how we will enter slowly into 3 dimension as far as repeated addition is concerned. These things are not available in any of the book. Anyone can try. Anyway, please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.